This is Note-Taking Guide 3.2 for Math 1. So today we're going to talk about interval notation and domain and range. So let's get started. The very first thing we need to know is what interval notation is. So there's some symbols that we need to remember about what we're talking about. So it says, first of all here, the interval notation has two types of symbols. It has brackets, which are these, and parentheses, which are these. Okay, brackets mean equal to. So equal to, less than or equal to, greater than or equal to. So anytime we would have in the past put a closed circle, that's the same thing that a bracket means. Parentheses, on the other hand, mean not equal to. So when there's not an equal to sign, when it's missing under the less than sign, when it's missing underneath the greater than sign, really anytime we would have done an open circle on a graph, this is when a parenthesis would be used. So really, and maybe just to explain, let's go back and look at this. If it says that I start at 4 and I go to 12 right here for my interval, that means I start here on my graph at 4, I end here on my graph at 12. At 4, it's equal to because of the bracket, which means it's got to be colored in. At 12, it's open because it's a parenthesis. And my solution is everything in between those two numbers because my interval starts at 4 and goes to 12. So an interval is just a group of numbers or a set of numbers that has a starting point and an ending point. So we start at 4, we end at 12. We can't be exactly 12 though, so maybe 11.999, but not exactly 12. All right, so let's look at how we can write an interval in interval notation. It says graph x is greater than or equal to 3 on the number line. So if we were going to graph this the way that we have in the past, we would start at the number 3 on the number line. It would have a closed in circle because of the equal to sign. So I got my closed in circle there. And I would be shading everything to the right because I want my x's to be shaded that are greater than 3. So 4, 5, 6, those are all greater than 3. So here's what it looks like. So now let's write the interval that describes this graph. So the question is, how far left and how far right does the graph go? Well, how far to the left does the graph go? The furthest it can go is 3. How far right does the graph go? Well, this arrow here on my graph means forever. In math, forever means to infinity. So then I need to decide whether or not I need brackets or parentheses around those numbers. Because this was a solid circle, a colored in circle right here, I know that that's the same as a bracket. A bracket means equal to. But I don't know where infinity stops at. So I don't know where that's equal to. So I have to use a parenthesis on that side. So this is called interval notation, where we just tell how far left and how far right our graph goes, or our solution set goes. So again, here's a couple more examples. Graph the inequality and write the interval to describe the graph. So we're going to do x is less than -6. So I'm just going to put -6 on my graph somewhere. It's going to be an open circle there because the equal to is missing. Less than would be to the left, so my arrow is going to come this direction. To write an interval for that, I'd ask myself, well, how far to the left is this graph going to go? Well, it goes on forever to the left, which would be to negative infinity because it's infinity to the left, so negative infinity. How far to the right does my graph go? Well, it stops right here at -6. Then I just need to ask myself if it's going to be parentheses or brackets around those. Well, we don't ever know exactly where infinity is equal to, so we know that's going to be a parenthesis. And then because this was an open circle, it was missing the equal sign there. I know I'm also a parenthesis on this side. All right, this next one, we talked about these a couple of chapters ago. I like to call these the sandwich graph because see how the x is sandwiched in between these two numbers? So what this really says here is x is greater than -2 and x is less than or equal to 7. But really what I know on this graph is that I am starting at -2 and I'm ending at 7. 2 is missing the equal sign, which means it's an open circle. 7 has the equal sign, which means it's a closed-in circle, which is hard to do on this iPad. And my answers are sandwiched in between those two values. So I'm sandwiched in between there like that. So we've graphed these before, so hopefully that is a reminder of how to do that. So then to write my interval, how far left does my graph go to? Well, my graph goes to -2. How far right does my graph go to? It goes to 7. Then I just need to decide brackets or parentheses. Well, open circle over here tells me parentheses. Closed circle down here tells me brackets, so I'm bracket around there. I want to point out to you that this 2 and this 7, they directly relate to the -2 and 7 right here. On these sandwich one, it tells you which numbers you can be putting in your interval. So just keep that in mind while you're looking. All right, so we're going to use interval notation now to help us find our domain and range. So what is domain and range? Let's read through this page and see if we can get it all straightened out. Each ordered pair has two parts, an x value and a y value. The x values of a given relation are called the domain. So x is domain, okay? The y values of the relation are called the range. So range is y. When you first list domain and range of a relation, you place each, the domain and the range, in a separate set of braces. So domain, left to right, input values, range, bottom to top, output values. So again, domain, because domain is x values. I want to remind you on a coordinate plane. If we're looking at a graph that we're graphing here, this is the x values, this is the y. So domain is x, it goes left to right. Range is y, it goes bottom to top. Why do we say bottom to top and not top to bottom? Because we always want to go from the lowest value to the highest value. So let's look at this and see if we can decide the domain and range on these. So this is just a set of ordered pairs that I need to decide the domain and the range from. So domain is my set of x values. So I want to know where my x values are equal to. These are all solid dots, so I know that these are all going to be equal to. So I'm going to just use a bracket to set my domain here. So domain are x values. That x value is 1. This x value is 2. This x value is 3. This x value is 4. X value is 5. And x value is 6. So my domain is a set of numbers 1, 2, 3, 4, 5, 6. My range, again, I'm going to use brackets because there's solid dots here. This time, though, I have to look at my y's because my range is my y's. So my first y value is -1. My second y value is 0. My third y value is 1. Then I'm at 2. Then I'm at 3. And then I'm up at 6 for the set of domain. So if I'm going to write my domain and my range, then over here on this little domain and spot and range spot, my domain is 1, 2, 3, 4, 5, 6. And my range is -1, 0, 1, 2, 3, and 6. The values that happen left and right and bottom to top. Okay. This one says find the domain and range of the function. So this time, this is a continuous curve. Every value between here and here is taken care of. It's all been continuous from the start to the end. And the same thing happens from bottom to top. From the bottom to the top, it has also been continuous. There's no holes in that graph from bottom to top. So what I need to do is I need to look at the domain, which is how far left and how far right my graph goes. So let's look left. How far to the left does this graph go? Well, the graph, it goes to here and it goes to here. So only in between those two spots does my graph go. So how far left does it go? It goes to -3. How far right does it go? It goes to 1. And remember on this, we're looking at the x-axis because domain is x. So then I just need to decide if I'm putting brackets or parentheses around here. This wasn't an open circle, so it's going to be a parenthesis. This is a closed circle where it ends, so it's going to be a bracket. All right, we're going to do the exact same thing now, but this time we're going to look at our y values for the range. So our y values, we're looking y along this axis. So how high does it go and how low does it go? But we start low to high. So how low did that go? It went to -4. How high does that go? It goes to 0 on the y-axis. Then I'm going to check to see if it's brackets or parentheses. Well, at -4, it was solid, so it's a bracket. Up here at 0, it's open, so it's a parenthesis. So left to right is domain, bottom to top is range. All right, find the domain and the range of the relation if it is a function. If it's not a function, write not a function. Well, the first thing we need to decide is whether or not it's a function. So let's check our x values. Do they repeat? Here's 3, here's 4, here's 6, here's 4. Well, that was lucky for us because those repeat. The 4 and the 4 repeat, which means this is not a function. And we don't even have to worry about range and domain if it's not a function. Okay. So same thing here, find the domain and range of the relation if it is a function. If it's not a function, write not a function. So let's check our x values. We have 3, 4, 5, and 9. So they didn't repeat, so we actually are a function. So let's write our domain and our range. Our domain is our set of x values. So we have 3, 4, 5, and 9. Our range is our set of y values. The only number in our range is the number 5 because it repeats the whole time there. So our range is the number 5. All right, find the domain and range of the relation if it is a function. If it's not a function, write not a function. So again, here we go, same thing. This is a line this time. So we got to decide how far to the left and how far to the right does our graph go. So just a little reminder, what do our arrows on the ends mean? It means that it continues on forever, right? So if this continues on forever, how far to the left is that graph going to go? It's going to go on forever, is going to negative infinity. I always know when I'm talking about infinities that I'm a parenthesis, not a bracket, so I'm just going to put my parenthesis around the negative infinity. And then how far to the right is this graph going to go? Well, it's going to go forever. So it's going to positive infinity for my how far to the right. Then on range, that's how low is it going to go? Well, this graph is continuing to go lower and lower and lower. So it's going to go to negative infinity as far as how low it's going to go. How high is it going to go? Well, it's going to keep going higher and higher and higher up to positive infinity. It goes forever. So my domain and range are the same this time. But remember, this one's left to right and this one's bottom to top. All right, last one here. This is my V-shaped graph. It's a relation. Well, if it is a relation, we're going to see if it's a function. If it's a function, we're going to find the domain and range. If it's not a function, then we're going to just say not a function. So vertical line test on this really fast. Vertical line test determines that this is a function. So we do actually need to find its domain and range. So how far left is this graph going to go and how far right is this graph going to go? So this graph is kind of hard to decide because we only have a piece of the graph and they didn't put an endpoint there for us. So we're going to assume that this graph goes forever in those directions because they didn't put endpoints there. So how far left is this graph going to go? Well, it's going to go forever to the left. So it's going to go to negative infinity. How far right is this graph going to go? It's going to go to positive infinity. But then when we look at bottom to top, how low does it go to how high does it go? It actually has a definite spot that it stops at on how low it goes. So there's -1, there's -2, -3. So we're actually at -4. We're down at -4 for where it stops. We actually know that it's going to be exactly at -4 there, so we're going to use a bracket. But how high does this graph go? It goes up forever. So we're going to use a parenthesis there around the infinity. All right, that's interval notation and domain and range. Come see me if you have any questions. Good luck with your homework.